Okay, let's go over the quiz, right? So the first one, find the limit. What method would you use? Direct substitution, right? Direct substitution means, you know, if this function has a limit at has a limit, then if you can plug in -2, then whatever the function value is, that ought to be it. Meaning, that's a polynomial. We know it doesn't have any breaks in the graph or anything. It's not a inverse variation, which would have a vertical asymptote. It's not a piecewise function. It's a smooth, continuous curve, which ought to have a limit at every point. And you can find it. If you can plug in -2 and get your answer, then you plug in -2. You got to show your work on this. A lot of times, you know, if you didn't get this right, it's probably because you did something wrong in the arithmetic, and a lot of times you didn't show it. So there's really hard to know, but maybe you wouldn't have made the same mistake if you showed plugging in. Am I still on here? If you showed plugging in 5 minus 2 times -2 minus -2 squared, right? That would have been 5 plus 4 minus 4, which is 5. So it's just simple, just plug it in. And there were some that missed, and there was no, you know, there wasn't work there, or you tried to skip over, like you just had a line right here where it looks like the result of what you thought you got there, but you actually didn't show the step, and there was something wrong because these numbers weren't right. Now, when you look at the problems like this, if you do direct substitution, you're going to get the indeterminate form. You're supposed to do something about that, right? The answer is not, oh, it's 0 over 0, no limit, right? What was the technique that we were supposed to use on the number 2? Dividing out, right? Which in this case, it's really, you don't have to do any polynomial long division. It's a pretty simple factoring problem, or it's supposed to be, right? It should have been x plus 1 over x plus 1 times x minus 6, right? I mean, that was the factoring part. Now, right, I can factor out the x plus 1, which means I am finding the limit as x approaches -1 of 1 over x minus 6, which is -1/7. Right? And still, way too many people on that one, I believe on that one too, that at this point here, when you cancel out, your next line is like the limit as x approaches -1 of x minus 6. Now, all of a sudden, that x minus 6 is in the numerator. What happened? I mean, how could that be? Or even you got to this point, and then your limit was -7. It's like not really understanding denominator and numerator stuff, which I don't have to tell you is arithmetic, right? You can't, is 2 equal to 1/2? No. So you can't just move things around like that. And we do that way too often. What was the strategy, the technique for this one? You multiply by the conjugate, right? What is the conjugate of that numerator? The square root of 3 plus the square root of x plus 2. It's the same expression, but that minus turns into a plus, right? So it should have looked like the square root of 3 plus the square root of x plus 2 divided by the square root of 3 plus the square root of x plus 2. Right. Now, when you FOIL, right, in the numerator, because these are conjugates, it's actually, you only have to multiply the first terms and the last terms. So the square root of 3 times the square root of 3 is 3. Right. The square root of x plus 2 times the square root of x plus 2 is x plus 2. Okay, and because it was a minus times a plus, that's a minus. Unfortunately, that's not right. What's not right about it? I mean, it has to be in parentheses. That minus is going to make even the 2 becomes negative. So if you added 3 plus 2 and got 5, that's why. right? That's not right. This, if you would have done this correctly, it would have been 3 minus 2, which is 1 minus x, which is the same as that factor in the denominator. That's the way these always work, right? It should be whatever you're simplifying in the numerator becomes that other factor in the denominator that was giving you a 0 in the denominator. So now we've got 1 minus x times the square root of 3 plus the square root of x plus 2. Okay, now we can cancel the 1 minus x's. Again, that's why, and there was a few that did this, you never want to start trying to simplify the denominator by foiling in this case, right? It's not always a FOIL, but in this case it would have been. Just leave it like that, because that 1 minus x is going to cancel, right? So now we get the limit as x approaches 1 of 1 over the square root of 3 plus the square root of x plus 2. Okay, what happens if I do direct substitution now? Yeah, I'm going to get the square root of 3 plus the square root of 3, which is 1 over 2 times the square root of 3. Right? It's not the square root of 6 or anything. There was a few other things like that. It's just 2 times the square root of 3 in the denominator. That's it. Okay. So this is the classic example of left-sided limits not equaling right-side limits, therefore there is no limit. Okay? It's not because when you plug in, you get 0 over 0. Obviously, we're getting 0 over 0. It's not defined actually at 3. Now, just, in case, there's maybe 1 or 2, I don't remember because sometimes it's in my 4th block, sometimes in my 2nd block. What does it mean when it says x approaches 3 and then has the little minus sign? It's a superscript there. Yeah, it's approaching the value positive 3 from the left. That's not a negative 3. There was a lot of plugging in negative 3 there, and that's just not right. That's saying we're approaching 3 from numbers less than 3. This is saying you're approaching 3 from numbers that are bigger than 3. Now, if you're approaching 3 from numbers which are bigger than 3, for example, if x equals 4, then 4 minus 3 would have been positive, and what's the effect of taking the absolute value of a positive number? Nothing. So basically for this one here, because this inside the parentheses, inside the absolute value brackets is positive anyways, this thing equals 1. Okay. This is the one because the values of x are as we approach are less than 3. If you have a number that's a little bit less than 3 and you subtract 3, you're going to get a negative number. And then what happens when you take the absolute value? It becomes positive. But the numerator is still negative. So it's negative 1. So that's the value of the left-sided limit. That's the value of the right-sided limit. All right. Then when you're asked for the overall limit, right, then you say does not exist because it's not enough just to say does not exist. I mean, that can just be a guess. You're just guessing that that'll work, right? There's a reason why it doesn't work, right? We saw actually 3 ways that a limit doesn't exist, and that was the number 1 way, right? And because these are not equal, that's why there's no limit. And this example comes up a lot. It came up in the first chapter when we were doing basic functions. It came up in the first section of this chapter, and then they readdressed it again in the second section of this chapter, both of which we are being quizzed on right here. So you want to remember this, I'm sure, in calculus, that they use this at the beginning as the classic example of a limit that doesn't exist. And you need to be looking at these expressions here and understanding what they're getting at here. The reason why that's -1 and the reason why that's 1. Right? You should not need a calculator to figure that one out. We should know that. The questions on the quiz? Okay. So I'm going to go over a preview review for the test that we're going to do on Wednesday. Right? At the end, I'll give you a list of all the problems all together as the study guide, but now I'm just giving you each section of problems and showing you what's there, right? Finding the limit of a piecewise function. Remember? Now, and it says, and the test says also, graph the function. So how do you graph a piecewise function? Another thing we've been doing since the first chapter. Yeah, what are these things right here? What's the word? It's domain, right? It's telling you the domain of this expression here is x less than 2. Not because there's a square root of a negative or divide by 0 or anything. They're just saying only use this function for x values less than 2. So if I was going to graph it, I would go, this has a y-intercept of 1 and a slope of 2. So it would look like this, right? There's the y-intercept, the slope of 2. So it would go up like this. For x values of x less than 2, it would actually, it's not or equal to. So it would have an open circle right there. And let's switch this to a red. This one looks like it's a line. It says a y-intercept of 3 and a slope of 1, right? So that would be, if I was going to draw the whole line, right, the y-intercept of 3 is there, and then the slope goes like that. It's just that this line doesn't start until you get to 2. So I'm not drawing the line here. I start it right there, and it looks like it includes that point, and it goes up like that. So when you do the graph part, if you end up drawing a graph that looks like, you know, that and that, there's going to be significant points lost. You've got to understand a piecewise function by now. You only graph one of them in any particular part of the domain. Okay, now on this one here, if I was going to say the limit, you know, from the left-sided limit, right, as x approaches 2 from the left, right, with the minus as a superscript, as an exponent, it would look like the function is approaching 5. And from the right-sided limit, it would look like the function is approaching 5. So it looks like the left-sided limit and the right-sided limit are the same. So the limit is 5. And again, with a piecewise function, I mean, you just plug in the 2 and see if you get the same thing. If it's not going to work, then when you plug in these values here, they're not going to give you the same function value. If they do, then you know, I mean, again, because we know what kind of graphs these are, right? These are straight lines. There's no break in it or anything. We don't have to worry about an asymptote or anything. It's just a straight line. So if the function values at 2 are the same thing, they're meeting at the same place. So it's going to be graph the function, say whether a limit exists, kind of thing. Okay, these are all the look and see whether a limit exists. X approaches -1. Honestly, the kind that we're more interested in, I mean, we should be able to do any of these, but I can't, oh, that's a comma right there. 5 over 2, I mean, what is e to the 1 over x? What's that? I mean, e to the 1 divided by x. No, we know what e to the x is. That would be like saying e to the negative x. And what kind of a function is that? That is exponential decay, right? Because of the negative exponent, we would expect that it looks like something like that. So let's see. If we let the x become, let's see, as it becomes 1 over closer and closer, as x goes towards 0, then the 1 over x is getting towards infinity, and e to that power would be, just again, look at that. 1 over x, if x is approaching 0, 1 over 0, we know we can't let it get to 0 because that would be undefined. But as it's not getting to 0, right? This is a limit. 1 over something getting really close to 0 is getting really close to infinity. And e to the infinity would be a really big number. So what would happen to the denominator here? It would become really big, and the value of the limit would be 0. It's not one that we've dealt with before. Should we be able to figure out? Yeah. I mean, I wouldn't put that on the test. This would have to be a 0. The ln of 7 minus x. Again, some of those are certainly things we could figure out, but we're probably a little more interested in some of these others here. And understand that this is in the first section. So if you looked at, for example, if we found the limit as x approaches 4 of this expression, well, what would happen if you did the direct substitution? You would put in a 4 there and a 4 there, and what would you get? It's actually not even, I think in a way it's almost like they made a mistake, that maybe that was supposed to have been minus 3. If that was a minus 3, then you'd have 4 minus 3, which is 1. The square root of 1 is 1. 1 minus 1 is 0, and it would be indeterminate form. But this is actually telling you, put it in the calculator and just see, does it look like it's approaching the same place? In this case, it's plus 3. So if I put in x equals 4, what I'm going to get is, this is not 0, but you're dividing by something that is, which means it's a vertical asymptote. So this thing would be approaching at x equals 4, and you could put it in your calculator and look, but at x equals 4, 2, 3, 4. It ought to be veering off towards infinity or negative infinity, like that. And what do you say about a limit as you're approaching a vertical asymptote? It doesn't exist. Clearly, if it's veering off towards infinity, then it's not limited. There is no limit. Probably a more typical problem would be something like that, number 40. Because what kind of a function is that? A constant divided by x. Inverse variation, right? That's the one that would have a graph that looks like a parabola, a hyperbola, but it would be shifted 3 to the right, right? So if I take this graph and I shift it 3 to the right, and then I take the limit as x approaches 3, you're approaching a vertical asymptote, so it would have no limit. So again, the intent of this is put it in the calculator, see whether you see, it ought to look like it's approaching the same from the left and right. It's probably undefined right at that value, right? Probably undefined. Okay, these problems here were direct substitution. So we all understand how direct substitution works? Okay. Again, it says if the limit exists, and basically if there's not a discontinuity right where you're going for, then you should be able to just plug in whatever value x is approaching, and that'll be your value. Look at something like number 49. 49, you're dividing by x. This thing's got a discontinuity at x equals 0, but you're not finding the limit as x approaches 0. So you'll be fine to plug in 3 and get what you get. Right? This one's got a vertical asymptote at x equals negative 2, but you're not finding the limit as x equals negative 2. So then you could plug it in. What about on something like number 51? Okay, this has got x to the first, and this has got x squared. Why wouldn't the limit be 0? Highest power in the denominator. Why wouldn't the limit be 0? What's that? Right. It's not a limit as this is going towards infinity, right? That's the other kind of limit. So you don't want to use that. This is a direct substitution. Plug it in. Find the limit. So this is the only section I've got from the second section, but it includes a couple different kinds of problems, right? It's got the dividing out technique, and it's got the rationalizing technique, both of which we just did. Now, if you have something that's fairly easily factorable, like number 9, right? X plus 3 times x minus 1, and then you divide them out, that works. What if you have something more complicated, like x to the 4th minus 1 over x minus 1? I mean, first, you try direct substitution, and you get 1 minus 1 is 0. 1 to the 4th minus 1 is 0. So that gives you the indeterminate form, and it tells you that x minus 1 must be a factor of the numerator. So how are you going to divide out x minus 1 from the numerator? I mean, honestly, yeah. Somebody say factor? How would you factor that, Ken? It's a difference of squares, right? X squared plus 1, x squared minus 1. And then x squared minus 1 is x plus 1 times x minus 1. There's your x minus 1. But you could also do long division or synthetic division, right? Since that's a to the 4th power, right? There's the 4th, 3rd, 2nd, 1st, minus 1, right? Synthetic division-wise, what would we put in the bracket if we're dividing out x minus 1? Positive 1. And then you go along. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. 0. Okay, so what would be left if I factored out an x minus 1? X to the 3rd plus x squared plus x plus 1. And then that you can do direct substitution on. It looks like the first bunch of problems here are all the dividing out technique, and then the last 4 are all rationalized, multiplied by the conjugate. Right? Actually do it, practice it, check your answers, make sure you can do it. Okay, then we get into the third section, which was about the slope of the tangent line and the derivative. So, use the limit process to find the slope of the graph of the function at the specified point. So remember, and you're going to be given this on the test, right? The formula for the slope is the same as what we're calling the derivative of the function, and that is the limit as h approaches 0 of f of x plus h minus f of x divided by h. And I'm giving you that on the test. You don't have to remember that part of it. Now, you know, in these first problems, if you went to the example in the book that they were doing at the very beginning when they were doing these, then they would have set it up like this. They would have said the limit as, what are we doing here? As h approaches 0 of f of 3 plus h minus f of 3 divided by h. They would have already substituted in the 3 for the x. So now when I go through this process, I'm going to get the value of the slope at that one point x equals 3. Now, your alternative to that is instead do this. Don't plug in the 3. Then you're going to get a formula for the slope, which will be m as a function of x. And then you'll plug into that formula x equals 3. Now, that formula will work for all values of x. This is going to limit you to one slope for one particular value of x. Now, you know, let's take, for example, the first one, just to show. And I'm going to do the do this and then plug in x equals 3 at the end. Right, so I'm going to first I've got to find f of x plus h. We got a phone to turn off? No. How do we find f of x plus h? This is always where we make our mistakes. That's f of x. What is f of x plus h? What's that? Plug in x plus h for x, right? So that's going to be x plus h squared minus 4 times x plus h. Is that what you meant, sir? Okay. And then you got to simplify it. Now, here's the place where you're going to make the mistake. The minus right there, you got to be careful that you distribute that minus. It's going to make it minus 4x minus 4h. We almost always make a mistake with that. So this is x squared plus 2xh plus h squared minus 4x minus 4h. Right? That's just the f of x plus h part. Right? The f of x part is this, right? X squared minus 4x. Okay, then we can subtract. Every term that does not have an h in it should cancel at this point. F of x plus h minus f of x equals x squareds cancel, 4x's cancel, 2xh plus h squared minus 4h. Divide by h. And again, because every term has got an h in it, you'll be able to cancel that one h in the denominator here, here, and here. Right, so this is going to be 2x plus h minus 4. Okay, now we're going to take the limit as h approaches 0 of 2x plus h minus 4, which is 2x minus 4, right? Because when you put in the h as 0, you're going to get 2x plus, Right? And that is a formula for the slope. You can call it m or m of x because it's a function of x. You could call it f prime of x. That is actually the derivative. Okay, now if you wanted to find the slope at this point, plug in x equals 3, right? F prime of 3 is 2 times 3 minus 4. 2. So, they've mixed all this around. First, we were calculating the slope at one point, and we were doing it like that. But then we came up with the idea, well, if we don't plug in the x value, we can actually get a formula for the slope. And then we learned that formula, that's the derivative. Okay. So then we get to these kinds of problems, which they specifically said, find the formula for the slope. So you wouldn't have the option of plugging in the x value first, because you want the formula so that then you can plug in the x values and find two values for the slope. Now, we did, this is a polynomials. The x to the third, that'll be a little bit more of a challenge. They're not going to be these. It won't be a fraction like that. We saw that in one of our homeworks. I think we did number 19, and that was a little bit of a problem. You had to, f of x plus h was 1 over x plus h plus 4, and then you had to subtract 1 over x plus 4, and you needed a common denominator and all that. But definitely these we should know how to do. I mean, remember, these radicals always turn into rationalizing technique. Right? This one, the f of x plus h would be square root of x plus h minus 1 minus the square root of x minus 1. Okay, rationalize. That's why we learned that technique, so we can deal with those. Okay, and now we're essentially doing the same thing, but now we're calling it the derivative. So those three sets of problems in the end are all asking you to do about the same thing. Find the limit of the difference quotient. Okay, this was, okay, find the slope of the graph at the point. Again, you could do that either way. You could like plug in. They said find the slope at that point. So you could start with f of 2 plus h, right? And then find the graph, the equation of the tangent line. So let's see. I'm going to tell you that the slope of this thing at x equals 2 is 4, right? M at 2, 3 equals 4. How do I find the slope of the tangent? How do I find the equation of the tangent line? If I know the slope and I know a point. Point slope, right? Y minus y1 equals m times x minus x1. So y minus 3 equals 4 times x minus 2. Solve for y. That's it. That's how you find the tangent line, right? You've used what we learned in the chapter to find the slope. And then you do something that you've learned a way long time ago. Right? But it comes up. I mean, it comes up even on the AP Calc test. Okay, then we got to all of most of these were our homework problems from last night. How do you find the limit as x approaches infinity? And remember, if it's a rational expression as a function, then you just use the three rules, right? Depends on the numerator, the degree of the numerator and the degree of the denominator, right? If the numerator has a higher power, like number 17, there is no limit. If the denominator has the highest power, like, I see one term, but is there another one? I don't see another one. If you take, for example, just that second term, 4 over x squared, right, denominator is a higher power, so what's the limit of that term? 0. And if they have the same highest power, then it should be the ratio of the coefficients of the highest power term, negative 4/3. And then we do the same thing for sequences. These are the exact 6 problems we did for homework last night because they don't have any others. We did them all for homework. Well, we did there were some like factorials and things like that, but we're not going to mess with that. But, you know, if they're just, looks like rational expressions, we should be able to deal with that. And then don't do that thing, but we should be able to find the limit as n approaches infinity of these. We did these 2 in the homework last night. There's 2 others you could try. Remember that when you're finding the limit of an expression that has more than one term, then you just break it up into 2 terms. Right? Find the limit of this term. Find the limit of this term. Minus 1. I mean, if you just look, anybody tell me just by looking at it, what's the limit of that expression right there? 0? It's 0. Right, this first term will be 1n squared over 1n squared, so that's 1. This one, there'll be n squared, and then you square it, you get n to the 4th, and you got n to the 4th there, so that'll be negative 1. 1 minus 1, 0. So those are all the problems that I just presented. Okay, let me